some more details on CANrange. It's one of the more popular sensors that we have for this year. The CANrange is a time-of-flight sensor. It measures distance. We have the ability to provide additional features such as
feel free to just pass it down and go through the line.
When an object is within a certain threshold, you're able to use it as a limit switch essentially. In particular, I wanted to take a little case study on 33, my alumni team. So they broke it up into two primary use cases. They've got the internal detection for use and making sure that the mechanisms don't go over a certain point, or for detecting game pieces inside the robot, those kinds of things. We have a couple of pictures of their CANranges being used in the robot. The first one being used for coral detection on their intake, similar for coral detection going through a funnel and inside their end effector. They make use of various different features such as the field of view configurability. The CANrange, being a time-of-flight sensor, has the ability to change the field of view. So at most it could be 27 degrees in range, and you can bring it down to at a minimum 6.5 degrees about. So they make sure that when used specifically for internal detection, that the CANrange isn't detecting its own robots and instead is focused on areas that the game piece is actually going through. For external detection, they're using it primarily for the reef in this game. They've got two primary CANranges that are used for reef detection. They've got one toward the bottom of the robot to detect how far away the robot is from the reef, and they actually use the raw distance measurement to figure out how much to adjust their elevator by. And similarly, they've got a CANrange on the end effector that's detecting the pole that the coral goes on, and they're using that as a final verification that the end effector is actually where it needs to be in order to score the coral. These two primary ways have been the most common cases I've seen that the CANrange be used for, actually, is to figure out that the robot is exactly where it needs to be in order to score the coral and improve the reliability of their scoring.
So the CANrange is a super flexible product. So it's simple. I have someone passing it around, but it's a tiny, like 1 inch by 1 inch square brick that has the ability to act as a limit switch, act as a distance sensor, and that can be introduced into a lot of different situations. I was having Madtown come up to me and talk about how they're integrating into their system, and you can actually go into Delphi and take a look at just on the front of the robot. They have two CANranges placed around, and as Corey mentioned, that detection for being able to adjust how far your arm needs to travel to compensate for when coral's stuck between you and the reef, that improves reliability so much, and reliability is critical to this game.
Okay. You said the minimum angle was 6.5 degrees?
Yep.
And you said the teams are using it to detect the pole of the reef?
Yes.
But the pole of the reef does not fill that 6.5 degrees.
Correct.
So the question is, how much of that 6.5 degrees do you have to fill to get a reliable reading?
So the way that the CANrange works, and basically all time-of-flight sensors work, is it emits a laser pulse. For the CANrange, is a class 1 laser in the infrared spectrum, and it measures the time it takes for that pulse to come back. What this results in is basically any object that is within that field of view will provide a return. The smaller the object it is, the less strong that return becomes. And we provide a way to measure how strong the response is. It's a signal strength parameter that we have with the CANrange. So it's going to depend on exactly how the CANrange is mounted to figure out how strong of a response it'll be for your particular application. But you can plot the distance and the signal strength, gain a characterization of what the object you're detecting is, and then set the thresholding parameters to.
User configurable.
Yes, this is a user configurable setting.
It's also going to depend on the color of what you're talking about.
Not so much the color, but more so the reflectivity of the
transparency
surface.
is infrared,
Yes.
For the purpose of this discussion.
Yep. And one other cool thing with the CANrange, since you do have the ability to reduce the field of view, you can also steer the field of view to be in a different direction. It doesn't have to be directly center aligned to the CANrange. You can bring it up, down, left, right, into a corner, however you want it to be. Oh. Yes, also software configurable.
Yeah. Right.
I see on your website the CANrange has 100 or 300 centimeter range distance, and it says 1 millimeter resolution. Is that accuracy, precision? Do you have accuracy, precision data?
In terms of accuracy, I found that it's typically around 5 centimeters accurate within 1 meter, 10 centimeters accurate within 2, and then 15 centimeters accurate within 3 meters. We don't have exact formal testing on that. This is just what I've experienced so far. So
in kind of into the formal testing, and part of that is dependent on a lot of factors, such as your lighting, material you're detecting, and the ambient noise of the environment. Those changes your factors, and that's why we offer a I think it's signal strength signal, and that you can use to determine how much you want to trust that measurement.